This video is going to be a training and demonstration of the Shear Connections attribute file creator. Here's the executable inside of the folder, and then there's a setup CSV or comma delimited file that you can edit in Excel. And then here are a set of standard saved away connections, which this has your typical default settings that are going to be used across all of your connections. And then here are example files that were programmatically created by this Shear Connections executable. So the very first thing that we would want to do is, let's say we're just going to grab all of this content and we'll copy it out of the generic folder here, and we'll just go into the model folder. And then what we'll do is we'll just go into the attributes folder and we'll paste all of those files in here. And you can see that I already had some standards there. All right, so once I've pasted those in there, in order for us to see those in the drop downs, we're going to go ahead and say open, and we'll just go ahead and reopen up this model here. We'll save the model, and then this will reread all of the attribute files here in the model attributes folder. Okay, so once we've done that, let's say we go over here to connection number 141 as an example, and if I just open up the dialog box here, we'll now see that there are all of those saved away settings. So if I load up W10-beam as an example, we'll see that the setback is set, the angle size, the angle material grade, stiffener size and material grades. Over here on the bolts will be set. The edge distances, the number of bolts, everything is set automatically. So what we want to do is we want to use the same naming convention from job to job. There's always going to be a W10 in the connection schedule, W12, 14, 16, etc. And you might have variations of this for specialized connections or something based on a connection mark in the connection design. But either way, you're going to have usually a pretty consistent naming convention here. So let's go ahead and go into controlling how we can actually set those up and change those. So we'll open up the Shear Connections attribute CSV file, and we'll open that up in Excel. And so this is pretty much how it works. If we just go ahead and auto fit the column widths here so we can see everything. You start with the connection number, so that's basically telling it, this row, which connection number is it associated to. The source file is basically the starting point file. So let's go look at 146 as an example here. When I do 146 and I load up standard, basically I came in here and I filled in things like the half-inch setback on the notch, the corner radius, maybe the typical marking system or something like that here, the naming convention. These are all things that are pretty typical and standard across all of the nominal depth connections here. So it starts with standard and it uses those settings, and then it programmatically replaces certain values and creates new attribute files from this standard seed file. Now you can save away things like skewed or full depth stiffener, whatever you want, and basically any of those save settings you can use as the starting seed file. So that's the starting file, and then here is the connection code as well as the new attribute file name. So we saw all those new files in the drop-down list, but what it also does is if I load up a W21-beam here, we can see that it also uses the same name as the attribute file name as the connection code here, which can be then applied to your connections in the model. All right, so everything else is pretty self-explanatory. There's the shear plate connection material grade as well as thickness. Then there's saying whether or not you want a far side stiffener or stiffeners are involved. Oftentimes in beam to beam connections it's not, but if you do want that on, like a far side full depth stiffener, you can switch that to on, and then basically you can just enter in the thickness values as well as the weld. In the case of beam to column connections, like where you use 186 and maybe 187, there is this far side stiffener thickness that you can enter. So if you had a moment connection, maybe you want the thickness to be 3/8 on the far side as well as the near side. I set it to 0 by default because usually you just want extend patch flange stiffeners on the near side only. So that's why they're 0 by default. But if we come in here, I'll show you an example of what I mean by that. If we go to 186, open that up, and we load, for instance, W24 going into the column web and we go to stiffeners, you'll see that 3/8 top and bottom near side, but 0 for the stiffeners far side, because we don't typically want far side stiffeners there. And so here I have the setting for the stiffeners on by default, but if you say no stiffeners, then it'll switch it to this, even though these values are entered in here. Okay, so one other special thing is that on 147, which goes to the top flange, here if you use any of these settings, there is a vertical edge distance property that you can set inside of the spreadsheet here. But the thing is that since this by default typically goes to the top flange, I don't programmatically fill this in based on the chart. I only fill in the bottom vertical distance. And then on 184, if we go to that one, basically if we just load in any of these properties, go to the bolts tab, you'll see that I don't fill in the top or the bottom vertical edge distance, because again this is a full depth stiffener and I'm expecting this to automatically just go to the top and the bottom flange there. When it comes to the welds sizes are set, but the weld type is expected to be defined inside of the saved away standard or seed file, but the sizes are filled in based on the Excel spreadsheet. Now, when you have a clip angle connection versus a shear tab connection, you'll see here underneath angle size for all the shear tab connections that I just put in NA for not applicable. But on the 141 connection, which is the only double clip angle connection that this tool supports right now, you can enter in the angle size and it will read that. When it comes to the angle, like the welded angle size, it's going to read the shear plate weld or the weld plate weld here, and it uses that as the weld size to work with, and then the stiffeners are separate. When it comes to slots, basically what the tool will do is you can enter in the added slot length here inside of the Excel spreadsheet. So let's go back up to the top, and there's a slot length value here. So for instance, when I switched these to 1-inch bolts, that needs to go to quarter. So for instance here I actually missed this on these particular examples, so I would just change that. And so you can just change those values based on the bolt diameter and then just save it. And just you don't want to save this as an Excel spreadsheet. You want to keep it as a CSV file because it just basically reads that programmatically. And so you can enter in that slot length and it will put that in here. And then if you say slots yes or no, what it's going to basically do is it's going to switch this between no versus slots in angles or slots in plates. In your standard or your seed file, you're going to want to have this as slotted if you do want slots versus oversize. And I believe default will also read slots because it's set that way in the joints.def file. But you just in your standard file, it's probably a good idea to set this. And what the tool programmatically does is it changes this value here of being in plates and angles or no if you don't want any slots there. And then you just decide what the slot length is in this value here. Okay, so let's actually run this and show you how it works. If we just come in here and let's actually go into the model folder because we pretty much copied everything in here. So we'll go back into the model folder, attributes, and then there's that executable. If we just go ahead and run this, basically what it does is it tells us to browse to that particular file. So we'll just come in here and we'll go to C, Tekla Structures Models, and then we'll go to our attributes setup, attributes folder. There's that CSV file. And it's looking for the standard seed files in this same folder, and the output files will also be created in this same folder. So we'll just say open. It then creates all those files programmatically, and then here if we refresh, it should show an updated creation date, which it does. And so again, if you just open these up with Notepad, you'll see that these values are just basically programmatically being replaced from that Excel spreadsheet.